Hi everyone, hi, welcome. Welcome people, hope you're all doing well. Hi guys. Hi Victor, hi Alicia. Nice to see you all here. Hello, welcome everyone. Jack, hi. Alicia, what the hell is a fuel cell? Hi, hope you guys are all doing well. Welcome guys. We're gonna get to questions very quickly. Yeah, we're going to be doing a live looking at chemistry paper 1 revision for tomorrow. Hi, Ab. Hope you guys are all doing well. Yeah, we're going to do chem paper 1 revision. So I'm going to cover a few of the topics that we need to know for tomorrow, things likely to come up. Mainly AQA, but like I say, this is always going to be helpful for everyone, okay? Combined and triple, it's helpful for all of you, okay? So make sure you guys get some notebook out or something to that effect so you can take some notes. Yeah, again, as usual, we're doing AQA mainly, but it's helpful for other exam boards. Triple mainly, but combined science stuff is involved in the triple stuff, and higher stuff mainly, but it's also useful for foundation people, okay? So we're going to get started very quickly. Make sure you all tap like. Let's get a few more people in here. I do my GCSEs next year. That's good. You can revise with us. You can be well prepared. So we're going to do a couple of topics. Let's get a couple more people in here. Let's all tap like and let's all get something to write on so we can get started very quickly. But yeah, I hope you guys are all doing well. Sorry I didn't do a live yesterday. I wasn't feeling too well yesterday. But I hope you guys are all well. And I hope you guys are all smashing the exam so far. You're not going to fail. You'll be just fine. All right. But yeah, thanks, Ab. But yeah, nice to see you guys here. By the way, everyone, for those of you who are here for the first time, on my website, christuition.myshopify.com, you'll find the GCSE 2023 predicted papers for maths and science that I've made for you guys. Okay, they're all instantly downloadable, so they come straight to your email. And what I've done for you guys, if you look on my website, you'll notice that I've put together bundles of the papers that are remaining, okay? So if you go on my website, here it is. You can see I've done all the remaining AQA higher triple science papers, all remaining AQA combined science papers. So you guys can just purchase the papers which are still remaining. Make sure if you guys are on my website, use the discount code LIVE30, okay? LIVE30, like in the top right corner of my screen. That will get you 30% off everything and bring the papers down to about 50-60p per paper. Okay, so go and check those out, guys. I've updated the mark schemes. There were a couple of mistakes in the chemistry mark scheme, which I've now updated. So whoever has already bought those papers, check your emails, check for the little errors that were there so you make sure you don't make any mistakes. And those of you who are going to get the papers now, you'll get the updated mark schemes, okay? So go and check those out, guys. Yeah, that's what the email's about, yeah. But yeah, we're going to get started. Like I said, hope you guys are all doing well. Yeah, the predicted maths paper 1, there was a lot of similarities actually, I was quite impressed with it, to be honest. There was a lot of questions that came up which are very similar, including like the Pentagon one and so on. So all the papers are on my website, christuition.myshopify.com. Okay, the link for that is in my bio. Okay, but yeah, we're going to get started now. Scarlett's getting annoyed with us, guys. So we're going to get started. Nice to see you guys all here, by the way. And like I said earlier, apologies to everyone. I did say I was going to do a live yesterday, but I wasn't feeling too well. So let's get started. Make sure you're all following and we're going to get started. So I'm going to get started on something first that involves everyone. You all should know this. Okay, so both combined and triple science students, all of you need to know this. So we're going to be looking at types of bonding, okay? And we should know that the three main types of bonding are ionic, obviously covalent, and metallic bonding, right? So we should all know that those are the three main types of bonding: ionic, covalent, and metallic. Yeah, some people are very eager. That's good. I like people who are eager to revise. So for ionic bonding, okay guys, what types of elements exhibit ionic bonding? What type of elements, what combination of elements exhibit ionic bonding? Ionic is metals and non-metals, right? So a metal and a non-metal will exhibit ionic bonding, okay? For example, we're talking about things like sodium chloride, right? Salt. So sodium's a metal, chlorine is a non-metal. So sodium chloride is an ionic substance. Okay, when we talk about covalent substances, what type of elements combine together for covalent bonding? We should all know this as well. Yeah, we're going to go through details. Yeah, non-metals, okay? So it's non-metal plus another non-metal. That will be covalent bonding, okay? And an example of a covalent substance, okay, would be things like water, okay, H2O, or nitrogen, N2, because there's two non-metals in there, or carbon dioxide. Very good. Okay, metallic bonding lastly. So with metallic bonding, obviously it's just going to be metals, right? Only metals, okay, and things here might be like magnesium, even things like alloy metals, okay? They all exhibit metallic bonding. So we should all be happy with this. This is the kind of very basics of bonding, isn't it? Let's go into a little bit more detail. Okay, so I also want you guys to remember that for ionic bonding, okay, in ionic bonding, it's the giving and taking of electrons, okay? So it involves giving and taking of electrons. Okay, so for ionic bonding, giving and taking of electrons. So it involves ions, okay? Whereas, as you guys are already correctly identifying in the comments, for covalent bonding, it is the sharing of electrons. And we're going to look at examples of these in a second, okay? So don't worry. Sharing of electrons, okay? And in metallic bonding, well, in metallic bonding, we have the attraction between positive metal ions and a sea of negative delocalized electrons, okay? So this is the attraction between positive metal ions or cations, okay, and sea of delocalized electrons. It's the attraction between those two, okay? Yeah, so we're always going to work from basics upwards to the harder stuff so that everyone understands what we're talking about, okay? It's the best way to do things. So feel free to take a screenshot of this because this is about to disappear off the screen. Make sure you guys are all following as well. And I'm going to clear this bit off the screen so we can continue going into more detail now, okay? And that's cleared. So next, let's look at examples of how we show how we show ionic bonding firstly, okay? So we spoke earlier about the example of sodium chloride. So e.g. sodium chloride. We said that this is an example of ionic bonding. Well, how do we show this? Firstly, I want you guys in your exam to look at where these elements are in the periodic table. So we know sodium is a group 1 metal, okay, and chlorine is a group 7 non-metal or halogen. Okay, so we've got group 1 and we've got group 7. Now, remember that ionic bonding, we know this is ionic because it's a metal and non-metal. Ionic bonding involves giving and taking of electrons. Okay, so we're giving and taking, so we need to decide what is giving electrons and what is taking electrons. And even more importantly, how many electrons. Okay, so the group tells us, yes, in the exam you get a periodic table. The group tells us how many electrons this element has in its outer shell. Okay, so sodium, if I was to draw sodium, okay, sodium has 1 electron in its outer shell. If I was to draw chlorine, chlorine's group 7. So how many electrons does chlorine have in its outer shell, guys? How many electrons are there in the outer shell for chlorine? 7, good. So we've got 1, 2, 3, 4, 5, 6, and 7. Okay, so since now we can see that sodium has 1 electron in its outer shell, chlorine has 7 electrons in its outer shell, and we know that a full outer shell is 8 electrons, right? We can decide that sodium is going to give its 1 electron to chlorine to fill its outer shell. So that electron there, okay, is going to leave sodium and it's going to be transferred to chlorine, okay, to fill chlorine's outer shell. All right? So remember that electrons are negative, right? So it's very nice of sodium. It's giving up its 1 electron to fill chlorine's outer shell, but at the same time, it's also making sure that it doesn't have some weird loner electron in its outer shell. It's now got a full outer shell as well, because the shell underneath this will be full. So it's helping itself and helping chlorine. Okay? Now remember, electrons are negative. So what will be the charge of my chlorine now that it's gained 1 of sodium's electrons? Can everyone tell me? It will be -1. Nice one, Adam. Nice one, Gio Alishu. Okay, so -1 charge on the chlorine because it's gained an electron. And therefore sodium, since it's lost a negative electron, what will be the charge of my sodium ion? I'll explain it again. +1, okay? So people are asking, why is it -1? It's -1 because there used to be an electron on sodium, which is a negative electron, and this negative electron has gone to chlorine. Okay, and since chlorine has gained a negative, right, if you've got another negative, that means you've become negative yourself, right? You've got more negative now. Okay, in the similar but opposite way, sodium was negative, but it's lost that negativity. If you lose negativity, you're more positive. Okay, hopefully that makes sense. It's a nice way to think about it. So, this is ionic bonding, and this is how we show it. So in this outer shell that it had here, there would be no more electrons for sodium, but remember that sodium has more shells, right? If we were to draw the full sodium, we know that sodium has another shell underneath that will already be full. Okay, make sure you guys draw square brackets around this, and outside of the square brackets, we show the charges. Okay, whenever you're showing ionic bonding, make sure you always show that a positive ion is next to a negative ion, because opposite charges attract. Okay, it's also something important. All right. Sounds like you need some sleep, Good, this is easy. I'm glad lots of you guys are finding it easy. Okay, so therefore, okay, overall, if I was to define ionic bonding, okay, if I was to define ionic bonding, I would say ionic bonding is the electrostatic, okay, electrostatic because we're dealing with positives and negatives, force of attraction between oppositely charged ions. Oppositely charged ions. So we should remember this definition as well. Okay, electrostatic force of attraction between oppositely charged ions. And now we can move on. Okay, so next we can move on to, I'll put this back up for anyone who needs to take a screenshot before I get attacked with it. And we're going to move on to covalent bonding, okay? So for covalent bonding, remember guys, we said that covalent bonding is the sharing of electrons, right? So we're sharing electrons instead of giving and taking them. Now, there's such thing as simple covalent structures. Okay, can anyone give me some examples of simple covalent structures? So simple covalent molecules. Water, good, H2O. Not salt. Chlorine, CO2, hydrogen, carbon dioxide, yeah, we've got that one. Methane, CH4, good. These are all examples of simple covalent molecules. Nitrogen, I can see. Very nice. Carbon monoxide, yes. Lovely. Okay, so those are simple covalent structures. Okay, so what's the opposite, or what's the other type of covalent molecule? If there's simple, there's also what kind of, yeah, things like graphene. What else are we talking about? Giant covalent. Good. So there's simple covalents and there's giant covalent structures. Now, when we talk about giant covalent structures, what are we talking about? Good. I'm seeing diamond. I'm seeing graphite, graphene, silicon dioxide. Yeah, things like C60, graphite, and allotropes, right? Graphite, graphene. Well done, guys. Okay, so there's a difference between these, right? Buckminster fullerene, C60, yeah. Very nice, guys. You guys have good knowledge here. Okay, so remember, guys, that when we're talking about giant structures, giant covalent structures, they're going to have very high melting and boiling points. Okay, they've got a lot more bonds to break. Bonds require energy to break. And so it's going to take a lot more energy to break these down, right? So we should all know that. And hence, we should know that simple covalent structures, they have lower melting and boiling points, okay? These guys over here are usually liquid or gas at room temperature, whereas these guys over here, the giant covalents, are generally solid at room temperature, okay? We should also remember that the reason why these guys, the simple covalents, are, yeah, nice one, Jay, that they're liquid or gas at room temperature, okay, is because they have weak intermolecular forces. Okay, weak intermolecular forces. Okay, and intermolecular forces are forces between the molecules. Okay, so between one water molecule and another water molecule, these forces are weak, so they're easy to break. Whereas in giant covalent structures, they're literally giant structures, which means that they're usually in 3D lattice structures, okay, all bonded together with lots and lots of bonds, which are very strong, and they require large amounts of energy to break down. Okay, good. Now, one thing that I especially want you guys to remember for tomorrow when you're answering these questions is something that students often lose marks on because the mark scheme is very specific. Okay, when you are talking, so listen up, everyone. I want you guys to all remember this. When there's a question asking about the melting and boiling points, okay, melting/boiling points question, melting/boiling points. Hope I've got everyone's attention, because if this comes up, and it's likely to come up, I want you all to get the full marks here. When we're talking about melting and boiling points, let's say you're saying that something has a high melting or boiling point. What you have to do is you have to say that the bonds are stronger, okay, or the intermolecular forces are stronger, and therefore, okay, therefore, it's this bit that I want you guys to focus on. Therefore, they require more energy to break or to overcome. Okay, this is often worth an extra 1 or 2 marks, and people don't say this, okay, and then they lose marks. So make sure you say this at the end of your answer. So if we're talking about stronger or weaker melting or boiling points, forces, which make up a higher melting or boiling point, we say, for example, we'd say the bonds are stronger, or the intermolecular forces are stronger, therefore they require more energy to break or overcome. Thank you, Harvey. So therefore they require more energy to break or overcome. Okay. If we're talking about lower melting or boiling points, we'd say, therefore they require less energy to break or overcome. So they have a lower melting or boiling point. Okay. So make sure we all remember this. If this comes up tomorrow, you guys are all going to remember my annoying voice saying exactly that. And hopefully you'll get those marks. So, the next thing I want to do is quickly show you guys how covalent bonding looks. Okay, so we probably all know this, but I'm going to show you guys anyway. Okay, Let's say we look at covalent bonding in water. Okay, so water, H2O. Okay, we know that water is made up of 2 hydrogens, 1 oxygen. We should know oxygen is group 6. Again, we'll see that on the periodic table. Hydrogen, like a group 1 metal, it has 1 electron in its outer shell. Okay, so if we were to draw the covalent bonding in water, okay, there's going to be 1 oxygen bonded to 2 hydrogens like this. Okay, so 1 oxygen bonded to 2 hydrogens. And then we can label those. So we've got oxygen, hydrogen, and hydrogen. Okay, we know that each hydrogen only has 1 electron to give because it's group 1. So hydrogen, let's put crosses as hydrogen's electrons, only has 1 each to give, right? So there's 1 cross from each hydrogen in the overlap. Okay, now the next thing that I want you guys to remember, that's oxygen over here. Okay, this is oxygen. Next thing I want you guys to remember is in the overlaps, okay, in covalent bonding, there's always the same amount of electrons from each element. So if hydrogen's given 1, it can only give 1. Oxygen must also give 1 in the overlap. Okay, here hydrogen's given 1, so oxygen must also give 1. Okay, and finally, everyone, since oxygen is group 6, there's 2 of oxygen's electrons in the overlaps. How many electrons are left in the outer shell of oxygen? Nice one, Adam. There's 1. Nice one, Sean. 3, 4. Nice one, Uma. And that's it. So that's how we'd show the covalent bonding. Why is it 4? Tell me. Okay, because oxygen is group 6, so it has 6 electrons in total in its outer shell. Okay, in the overlap there's 1. In the overlap there's 2, so there's only 4 left for oxygen. Okay, so 1, 2, and then 3, 4, 5, 6. So 6 in total there. And we can see by doing this, okay, everyone's happy. Hydrogen has a full outer shell. Oxygen has a full outer shell because oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, hydrogen is happy because it's only got 1 shell. Remember, the first shell only holds 2 electrons, and this hydrogen has those 2 electrons. Oops. Sorry about that. This is called a dot and cross diagram. All right, there is a lot of content. All right, I hope we're all happy with that. So let's move on. Just having a look at what you guys are asking. Some people want to go through questions. We could go through questions. I think there's some more content to cover. But we can go through some questions as well. Something that's likely to come up in exams as well, guys. Let's go through something that's likely to come up. Okay. Limitations of models is something that's likely to come up as well. They like testing on this. Okay. Limitations of models. So when we talk about limitations of models, guys, okay, we're talking about why things like dot and cross diagrams are good, why they might be not so good. Dot and cross diagrams, things like the ball and stick model, things like the 2D models. Okay, we should be able to talk about the pros and cons of each. Okay, so for example, guys, with the dot and cross, okay, we should know that it's useful because it can show us the transfer of electrons. Okay, it's useful because it shows where electrons are coming from. Okay, but the disadvantages of the dot and cross diagram is it doesn't show any 3D structure. Okay, it doesn't show the relative sizes of the atoms. Yeah, it doesn't show us the shape. Very good. The ball and stick model, on the other hand, has that advantage. It does show us how the atoms are arranged in 3D. Okay, it does help us to visualize what the molecule looks like, but a disadvantage is it doesn't show electrons. It shows that the atoms are spaced apart, whereas in reality, the atoms would be kind of touching each other. As I drop my pen. Yeah, in reality, there's no gaps, right? Good stuff. Okay, and then the 2D model, well, in a similar way, we should know that the 2D model doesn't show us the electrons. It doesn't show us the 3D arrangement of the atoms. Okay, I'll be posting this on YouTube right afterwards, so you guys will all be able to watch over this again. Okay. Why am I going fast? Sorry. I will post this on YouTube for you guys, so you'll be able to watch it this evening and revisit anything that you weren't sure about, okay? So don't worry. I was just going fast because I wanted to go through the important bits very quickly with you guys. Okay. Somebody's asking to do balancing equations. I think what time will I post on YouTube? I'm teaching again quite soon, so I'm gonna try and let TikTok do its thing and process the video. Then I'll post it straight afterwards whilst I'm teaching. Okay, for those of you asking, the YouTube account, if you type in Tutor Chris like this on YouTube, Tutor Chris, Chris with a K and double S, you'll find me there. Okay, so it will be there. I'd say latest by like 4 o'clock it will be there, okay? Because TikTok has to process the live and turn it into a video for me first. Okay, guys? I will also do another live. Now, you guys are going to ask me when I'm going to do another live, and I'm going to try and remember my schedule off the top of my head. I believe it's going to be at 6 or 5:30. 5:30 or 6. And at 5:30 or 6, we're going to do quantitative chemistry. Okay? Yeah, we're going to do quantitative chemistry, which is the calculation stuff. All right, guys? And perhaps electrolysis as well. All right, so that's what we're going to do at 5:30/6. So make sure you guys are all following so you guys see when we go live later on. And whilst I still have you guys hit, so make sure you guys all join around 5:30. I think it's 5:30 or 6 p.m. We're going to go through the harder stuff, the calculation stuff. And I want you guys to all, in the meantime, whilst I'm away, I'm teaching, go and check out my website, christuition.myshopify.com. You can take a screenshot of this page and you can go and check it out later. And make sure you use the discount code LIVE30 on my website, guys. Okay. Both lives will be on my YouTube, yes. On my website, you'll find the GCSE Maths and Science predicted papers. And like I showed you guys earlier, if you go on my website, here it is, christuition.myshopify.com. On the front page, you'll find that I've put into bundles the remaining papers for this year's examination period. So you don't buy the bundle of all the papers when biology is already done. You can just get the papers that are remaining, okay? So go and check those out. And like I say, use the discount code LIVE30. It will get you 30% off all the papers and bring them down to about 50, 60p per paper. Yes, both lives, Lisa, will be on my YouTube later. So guys, I'm going to finish up. So make sure you guys are all following. Make sure you guys all follow. And I'll see you all at 5:30 or 6 p.m. Nice of you guys to come. Nice of you guys to come. And again, at 5:30/6 p.m., I'm going to see you guys and we're going to do quantitative chemistry and perhaps electrolysis as well. We started at 1:15. But like I say, if you missed it, don't worry. It's going to be on my YouTube and I'm teaching from 2 p.m. Yeah, I'm teaching from 2 to 4 and then 4 to 5:30, I believe. So it will be at 5:30, the live. In it, Lisa. Lisa's here today. Nice to see you, Lisa. Yeah, it hasn't been an hour. It's been about 40 minutes almost. But like I say, it will be on my YouTube, so don't worry if you missed it. Lisa responding to Lisa. Nice seeing you guys. Like I said, later on, we're going to be doing quantitative chemistry, electrolysis, some harder stuff. We're going to go through questions together. All right? YouTube is here. Tutor Chris. Type that into YouTube. You'll find me. And make sure you guys all go and check out that website, christuition.myshopify.com. The link for that is in my bio. Get yourselves those GCSE 2023 predicted science papers. Get the chemistry paper, do it, and go and mark them as well. The mark schemes come. Everything comes instantly, okay? So people worrying about postage, it's not being posted. It comes straight to your email, and you get to revise those papers before tomorrow's exam. The maths paper one, there was a lot of questions that came up in my paper and the real paper. I was really impressed with maths predicted paper. It was really, really good. So maths was really good. And I'm also creating a maths paper 2 and maths paper 3 based off the maths paper 1. So yeah, it'll be even better than what's out there already. But yeah, I'll see you guys very soon. I'll see you guys at 5:30, okay? Take care, guys.